Good morning, afternoon, or evening. How you doing today? Welcome back to Mr. Morrow's algebra class. We are done with our review, and now we're going to move on to Chapter 1. We're going to talk about Lesson 1-1 today, variables and expressions. In algebra, we're going to be dealing with a lot of variables, and variables are basically unknowns. They are unknowns that represent a number. We're going to go over all sorts of definitions today, and hopefully you'll get a good understanding about how to work with variables and what expressions are. And this is the building blocks for the rest of the year. Everything in the beginning of this chapter is very important, and you will see it again and again throughout the year. So let's focus and make sure we really understand everything that's being taught today. First of all, let's talk about some basic concepts like a quantity. A quantity, okay? A mathematical quantity is anything that can be measured or counted. Some quantities remain the same, those are known as constants, or some vary or change, those are called variables. So anything that can be counted is a quantity. The number of cars in the driveway, that's a quantity. The number of toes that you have, that's a quantity. The amount of money you have in your wallet, that's a quantity. The amount of money you make per year, that's a quantity. The number of slices of pizzas you eat, that's a quantity. Anything that can be measured or counted. 7 inches, that's a quantity. 12 feet, that's a quantity. Okay, pretty simple. Variable. A variable is a symbol, usually a letter, that represents the value of a quantity. We are going to have to shift from using the x as multiplication because x is a very, very popular variable. Okay, we can no longer use that for multiplication. So from now on, 2x3, that's not going to work. You cannot represent multiplication like that. Represent it as 2 times 3. Please remember that when a number is next to another number and it's surrounded by a parenthesis, that means multiplication. How do you know if it's being added or subtracted? There will be a plus or minus sign in between. So if I have 2 plus 3, okay, that's adding. But if I have 2 times 3 there, there's no plus or minus in between, that's multiplication. Same thing with variables. If I have 2x, that is 2 times the value of x. I can separate it with the plus or minus sign, and then I add or subtract. But if I have them next to each other, it is just multiplication. So x will no longer be used to represent multiplication. Please be aware of that. And you could use any letter for variables. I usually use x or n, sometimes w or c or t, depending on what they're asking of me. Sometimes in word problems, it's good to have different letters representing something that has meaning within the actual problem, so you can really understand it. Okay, numerical expression. A numerical expression is a mathematical phrase or sentence involving numbers, operation symbols, but no variables, just numbers and operation symbols. So a numerical expression could be something like 3 plus parentheses 6 minus 12. That's a numerical expression. It uses numbers and operation symbols. Remember that the operation symbols are addition, subtraction, multiplication, and division. What's an algebraic expression? Well, an algebraic expression is a numerical expression which includes one or more variables. So basically it's the same thing as a numerical expression except you're adding variables. So for example, 2x plus 3, that's an algebraic expression. Or x minus y plus z divided by 6. That's an algebraic expression. A number sentence involving numbers, variables, and operation signs. And last but not least, a constant. A constant, okay, is a value that does not change. So for example, in an algebraic expression, if I have 5x minus 3. The value of this x can change. Therefore, the value of this product, 5 times x, can change. But this negative 3 here, that's forever. That's constant, and it will not change regardless of the value of the variable. So for example, let's say that x equals 2. In that case, 5 times 2 minus 3, that's 10 minus 3. This value changed because the variable changed. But this 3 is still the same, so you'd have 7. All right, so a constant is just a number by itself, something that cannot change, something that cannot vary. All right. Now, in order to translate word phrases into algebraic expressions, you have to look for keywords that describe mathematical operations. And these keywords are very important. So please, please pay attention. Please make sure you understand everything we're talking about here. Let's first talk about the operation of addition. For addition, we have sum, plus, more than, total, increased by, more, increased, add, added to. All of those words indicate addition. So if you see the sum of a number and 5, the sum of a number and 5, that's x plus 5. Any one of those key words is going to give you an expression, okay, of addition. Now, let's talk about multiplication. Multiplication, product, times, of, multiplied, per. Any of those key words indicate multiplication. So, let's see, for example, 2/5 of 10. Of means multiply, so 2/5 times 10, and that's going to be 4. Okay? Now, I want you to pay attention to this word here, per. Per can be used for both multiplication and division, and it really depends on how they phrase the expression. For example, if I tell you DVDs sell for $5 per DVD, and I tell you find the total price of purchasing 8 DVDs. Well, easy. Since it's $5 per means for every, and you bought 8, 8 times 5, $40. Okay, so pay attention to how the per is used. Subtraction. Subtraction, you're going to see things like difference, minus, less, less than, decreased, decreased by, reduced by. Let's focus really quickly on less and less than. When you see less, less is just straight up subtraction. For example, if I tell you a number less 8, that's simply x minus 8. Less is just straight up subtraction. However, if I tell you a number less than 8, okay, that's a little different. Whenever you see the keywords less than, think switch. Okay, switch. You're going to switch the last value for the first value. So basically, what does that mean? A number less than 8 is 8 minus x. You switch the last value for the first value. Less than means switch. Okay, that's a big one. A lot of people mess up with that, so please be careful. Okay, let us continue. Division. Quotient divided by, divided into, divided, per, out of. Let's look at the per for division. Let's pretend that we have the same example, okay, where DVDs sell for $5 per CD. I could switch this around and ask if your total bill was $80, how many DVDs did you purchase? Well, in this case, we're going to use per as a division, because since it's $5 per CD and you bought $80 worth, well, 80 divided by 5, we're talking, what is it going to be? That was a bad number to use. Let's use 100. Make it easier for us. It would have been 16, but 20. You bought 20 DVDs. Okay? So please be careful on that per. Okay. Equals. We're talking is, was, were, will be. Any tense of to be. Okay? Is, was, were, will be. Any tense of to be means equals. And we're going to also work eventually with inequalities. So inequalities, please be careful. Look at what happens here. Is greater than, okay, or equal to. Well, let's see. Is greater than, I should have put, or equal to. Is greater than is just like that. Is less than or equal to. Less than is just like that. Is at most, we're talking about less than or equal. And is at least, we're talking about greater than or equal. Now, let me explain some of this. Please notice that if I were to take away the is, greater than would just be addition. If I tell you a number greater than 5, that's x plus 5. But once I add that is, that symbolizes to me, okay, we're talking about an is, we're talking about an equals, but is greater than, we're talking about an inequality. So the is activates the inequality. So if I tell you now, x is greater than 5, that would be x greater than 5. If I say x is greater than or equal to 5, x is greater than or equal to 5. So the is activates the inequality. Now, let's talk about at most and at least. A lot of times in word problems or just writing simple expressions, you're going to see at most and at least. And they're reversed. At most, you're talking about less than or equal to. At least, you're talking about greater than or equal to. And I always like to teach this with age. Let's look at it this way. You guys are pretty much freshmen, okay? So you are at most 15 years old. That means that you, the student X, is at most 15. That means you have to be less than or equal to 15 years old. Or I could reverse it, and I could say, okay, they're freshmen. They have to be at least 14 years old. So X, the student, is at least greater than or equal to 14 years old. Okay? Mr. Morrow is at most 40 years old. So he is less than or equal to 40 years old. Mr. Morrow is at least 30 years old. That means Mr. Morrow is greater than or equal to 30 years old. So please remember that when you have is greater than, is less than, the is activates that, okay? Is at most, is at least. That is activating the inequality. All right, let's put this stuff to work. Now let's practice writing word phrases into algebraic expressions. Okay, 2 times a number increased by 5. Well, 2 times a number is my unknown, so 2x increased by, that's addition, by 5. The product of a number and the sum of 12 and 9. So the product, that's multiplication, of a number, that's my unknown. So the product of a number and the sum of 12 and 9. When they're talking about the sum of 2 digits, you have to encapsulate them in parentheses. So the product of a number, x, product, times the sum of 12 and 9, 12 plus 9, and that would equal 21x. Okay? But that's how you write that expression. 5 times a number less than 15. Immediately, less than, switch, my friends. Take the last value and put it in the front. Take the first value and put it in the back. So 5 times a number less than 15 is 15 minus 5 times a number. Let's look at it in red. Let me just show you the difference. If I had just told you just less, let's just pretend it's just less. 5 times a number less 15 would be 5 times a number minus 15. Because when it's less, it's just straight up subtraction. When it's less than, though, in blue, you switch the first for the last. So 5 times a number less than 15 is right here in blue. Switch. Okay, number 4. 7 less 3 times a number. It's just less, so that's straight up 7 minus 3 times a number. 7 less than 3 times a number. Less than, switch. 7 less than 3 times a number. 3 times a number minus 7. 9 less a number. 9 minus a number. Less is just straight up subtraction. The sum of twice a number and 12. The sum of twice a number and 12. So 2 times a number plus 12. The product of 1/2 of a number and 1/3 of the same number. So the product of 1/2 of a number. So 1/2 x, actually, let's write this the right way. When you have 1/2 x like this, please note that the x is in the numerator. So you could write it like that, or you could just write x over 2. Okay? Make sure you realize that the x is in the numerator. So 1/2 of a number, 1/2 times x, the product, so times 1/3 of the same number, 1/3 of x. And there you have it. Alrighty, let's continue. Whenever we're dealing with expressions or any type of math, really, we got to follow the order of operations. I know we already saw this. I want to repeat it again, though. I want to make sure that you really understand this. Please excuse my dear Aunt Sally. Please, parentheses first. Excuse exponents. My dear, multiply and divide in order from left to right. Aunt Sally, add and subtract in order from left to right. Okay, number 1, parentheses. Perform any operations inside grouping symbols such as parentheses, brackets, braces, or absolute value. Those are all grouping symbols. Number 2, simplify powers, exponents, in order from left to right. Number 3, multiply and divide in order from left to right. And the last thing you do, my friends, is you add or subtract in order from left to right. Okay. Now that you kind of understand how to write expressions, you know how to follow the order of operations, let's talk about evaluating expressions again. You evaluate an algebraic expression by replacing each variable with a given number, then simplify the expression by using the order of operations. Very simple. Let's see if we can figure this out. What is the value of the expression for x equals 5 and y equals 2? Well, I have x squared plus x minus 12 divided by y squared. Plug it in and solve. So I have 5 squared plus 5 minus 12 divided by 2 squared. Okay. Let me go ahead and take this here. And let me put it here. Okay. So I've got 5 squared. I don't have any parentheses, so I got to do my exponents first. So that's 25 plus 5 minus 12 divided by 4. Multiplication and division in order from left to right. So I've got 25 plus 5 minus 3. Now addition and subtraction in order from left to right. 25 plus 5 is 30, minus 3 is 27. And that's that. How about 3x minus y squared when x is 5 and y is 2? I'd have 3 times 5 minus 2 squared. Whenever they give you a value of a variable, notice how I did that. I put it in parentheses, okay, because that value is going to be squared. Okay, 5 should have been put in parentheses as well. That way, if it's negative, you're squaring the negative. If it's positive, you're squaring the positive. So this is 15 minus 2 squared is 4, and that equals 11. Okay. How about find the value of xy squared for x equals 5 and y equals 2. And then I want you to compare your answer to, in parentheses, xy squared. What can you conclude? All right. Let's first try x, y squared. Well, I have x is 5 times y is 2 squared. And that's going to give me, please be careful, do not multiply 5 and 2 first. Follow the order of operations. Exponents come before multiplication. So this is going to be 2 is affecting the 2 inside the parentheses. And that's it. Anything to the left of the parentheses, anything to the left of the exponent is affected directly to the left, or anything inside of parentheses. So this is 5 times 4, which is 20. Now, let's look at the difference here. In parentheses, xy squared. Here I've got 5 times 2 squared. In this case, my friends, we have to do what's inside the parentheses first. Okay? The exponent affects everything inside the parentheses. So 5 times 2 is 10, which is inside the parentheses, and it's being squared. 10 squared is 100. Okay? Hopefully that makes sense. Let's do some practice problems. Okay. I got y divided by 2 plus x when x equals 1 and y equals 2. So I've got y over 2 plus x. Okay. X equals 1 and y equals 2. So I've got 2 over 2 plus 1. So that equals 1 plus 1, which equals 2. Done. A minus 5 minus b, where a is 10 and b is 4. So a, which is 10, minus 5 minus b, which is 4. 10 minus 5 is 5, minus 4 is 1. Okay, let's skip down a little bit. Well, hopefully you got those. I got to erase those. Please get those down. All right. Let me go to a little tougher ones. All right. How about this one? Number 10. 6q plus m minus m when m is 8 and q is 3. So I've got 6 times 3 plus 8 minus 8. 6 times 3 is 18 plus 8 minus 8. 8 plus 8 is 26 minus 8 is 18. Okay, hopefully you got that one. Let's do 11. P squared times m divided by 4. So I've got p squared times m divided by 4. All right, where m is 4 and p is 7. So I've got 7 squared times m, which is 4, divided by 4. So I've got 7 squared, which is 49, times 4 divided by 4. 4 divided by 4 cancels into 1, and my answer is 49. All right. Let's do a couple more, and I'll let you go. Let's see here. All right, let's see. Let's do a 17. I've got 6 plus h squared minus j divided by 2. So I've got 6 plus h, which is 6 squared, minus j, which is 4, divided by 2. Okay? Got to go inside the parentheses. Inside the parentheses, I got to attack the exponents. So this is going to be 6 plus 36 minus 4 divided by 2. 6 plus 6 is 42 minus 4 divided by 2. 42 minus 4 is 38 divided by 2, which is 19. Okay, so I hope you're getting the hang of that. This is here on kudasoftware.com, so if you want to continue, you can. Answers will follow at the end of the PDF. I hope you learned a lot today. Practice hard, focus. Thank you very much. Have a great day, and goodbye.